Hello my friends, I am Krishna and welcome to my channel CoMath. So in this video I will tell you about types of function on the basis of mapping. So let's start the video. So there are basically three types of functions on the basis of mapping. These are 1 1, onto, or 1 1 and onto. Let's read about them in briefly. So what is a 1 1 function? So if a function is said to be 1 1 function if for the function each element of the domain is related to every different element of the domain. It means if the image of every different element of the domain is different, then the function is considered as 1 1 function. Now let us see some examples. I will give you examples of mapping. Let's see. Suppose we have two sets x and y. We again draw these sets as x and y. Now in the set x we have 4 elements, 1 2 3 4, 1 2 3 4, and in the set y we have 5 elements, a b c d e f. Sorry, 6 elements in here also, a b c d e f. Now under function f1, all the elements of the domain x are related to different element, every different element. It means image of every different element 1 2 3 4 is different, b c d e respectively. And under function f2, the element 1 and 2 have same images b, while the element 3 has an image d and an element 4 has an image f. So here the function f1 is considered as 1 1, while the function f2 is not 1 1. As you can see that for each different element in the domain, it means for element 1 2 3 4 each are different, there is a different image in the codomain y under function f. These are b c d e. Now the function f2 is not 1 1 because the element 1 and 2 have same images b in the codomain y. Hence the function f2 is not considered as a 1 1. Now let us solve. It's the time for definition. It's a time for a perfect definition, that how we define the 1 1 function. So let's see how we define a 1 1 function. So a function from set x to set y such that the image of every different element in set x is different under function f. Now let us again take an example. For example, consider the set x is equal to 1 2 3 4 and the set y is equal to 1 4 9 16 25, and a function from set x to set y such that fx is equal to x square is given in the roster form by, and given in the roster form as 1 comma 1 2, 4, 3, 9, and 4,16. So here as you observe that for each different element, it means 1 2 3 4, we have a different image in set Y, that is 1 for 1, 2 4 for 2, 9 for 3 and 16 for 4. Hence the function fx is equal to x square for the set x and y is 1 1. Now let us consider what is onto function. So basically an onto function, for an onto function, if the range of the function is equal to the codomain of the function, then the function is considered as an onto function. And in the other way, if we want to define, we say that if each element of the codomain acts as an image for an element in the set, in the domain set, then the function is considered as onto. Let's see how. Not how, let's see an example. I'm joking, friends, I'm joking. Let's see an example, not how. I can't tell how. So consider two sets x and y again, and the element in the set x are 1 2 3, and the element in the y are a b c. Again the set, draw set x 1 2 3 and the set y a b c. Now under function f1, each element of domain is related to different element, while under function f2 the element 1 and 2 have same images, while the function 3 has an image c. So here we observe that the element a of the codomain is not related to any element of the domain under function f2. Hence the function f2 is not an onto function, while the function f1 is considered as onto function, as each element a b c is related to every element of the domain x, or each element of the codomain y acts as an image for each and every element of the domain x. I hope you understand. Now it's the time for a perfect definition. Now it's the time for a perfect definition. That how we define an onto function. So चलिए देखते हैं. A function from set x to set y such that for every element y in codomain y there exists an element in domain x. Let us see another example. That is, again consider a set 1 2 3 and the set y 2 4 6 and a function from x to set y defined by fx is equal to 2x. Now in roster form, the function fx looks like 1 2 2 4 and 3 6. So here you observe that each element of the codomain y, it means 2 4 6, acts as an image for each element in the domain y, that is 2 for 1, 4 for 2 and 6 for 3. Hence the function f is onto function. So it's the time for the bijective function. That what is bijective function? And also onto function is known as surjective function, while one function is known as injective function. So it's time for the bijective function. So a bijective function is basically a function which is both 1 and onto. So a 1 and on a function which is both 1 and onto is considered as a bijective function. Let's see a diagram. Let's see an example. Again, consider two sets x and y, and the elements in x are 1, 2, 4, 5. I choose some different, and the element in y are x, y, z, a. Now, under function f, all the elements of the set of the domain x are related to every different element in the set y. So here you observe that for each different element of the domain x, we have a different element in the codomain. So function f is 1, 1, and also every element of the codomain y acts as an image for any element of the domain x. Hence, function f is also considered as onto. On combine, we say that the function is 1, 1 and onto both, or bijective function. So this is the whole topic. Now it's the time for defining the bijective function. But I don't define, because I think you can make this. I will give you two questions for checking their surjectivity and injectivity. It means check that they are 1, 1 and onto or not. And please comment me in the comment box that they are 1, 1 or not. A function from a set of natural number to the set of natural number given by fx is equal to x square, and a function from real number to real number given by fx is equal to x square. Okay, so tell me in the comment that these function injective or surjective or both. I hope you understand it. If so, please like the video. In case of any problem, you can comment me in the comment box. Thank you for watching the video.